Right now, in 2026 telescopes around the world are pointed at a single object. This object has quietly split the astronomy community in half. This isn't an old discovery pulled out of an archive to fill a slow news week. The peer-reviewed paper on it only became official a few months ago. Scientists are at this exact moment fighting for time on Hubble and the James Webb Space Telescope just to get a second look at it. It all traces back to something a graduate student stumbled onto while sitting in front of a computer screen at Princeton. He was scanning through 19 fuzzy telescope images. He was hunting for one specific kind of object. It was the kind astronomers had been chasing for almost a decade. It was the kind that was supposed to prove one of the biggest theories in modern astronomy. Instead, he found something that did the opposite. He found something that, according to the math, might actually break that theory apart. Nobody has announced a name for it yet. It doesn't have a nickname. It doesn't have a mission patch. It doesn't have a press conference with a countdown clock. Right now, it's known only by a string of letters and numbers. 2017 of 201. But what it represents is far bigger than its unglamorous label suggests. This single object is drifting silently through the darkest, coldest region of our solar system. It is currently forcing some of the most respected astronomers on Earth to quietly reconsider a theory they've spent 9 years defending. Here's what almost nobody explains properly when this story gets covered. This isn't really a story about one rock in space. It's a story about a hidden planet that might not exist. It's a story about the 90% of our own solar system that we still can't see. Stay with me. By the end of this, you'll understand why an object smaller than a mid-sized city has some of the most brilliant minds in astronomy questioning nearly a decade of work. You'll understand why the answer to what did they actually find is stranger than a simple yes or no. To understand why 2017 of 201 matters, you have to go back to 2016. That's when a discovery made headlines around the world. It briefly convinced half the planet that a ninth planet was hiding in our own backyard. 4 years astronomers Konstantin Batygin and Mike Brown had been quietly staring at something strange. A handful of distant icy objects orbit far beyond Neptune in the freezing outer reaches of the solar system. They all seem to be lined up in a way that shouldn't happen by random chance. Their orbits pointed roughly the same direction. They were tilted at similar angles. They were clustered together like a group of strangers who had somehow all agreed to stand in the same corner of a massive empty room. Batygin and Brown ran the numbers. The odds of that clustering happening randomly were about 1 in 14,000. There was only one explanation that made physical sense to them. Something massive out there in the dark was gravitationally herding those objects into alignment. It wasn't a planet anyone had ever seen. It wasn't anything in any textbook. They proposed a hidden world 5 to 10 times the mass of Earth. It orbits the sun so far away it would take somewhere between 10 and 20,000 years to complete a single lap. They called it Planet 9. It was a sensational idea and it spread everywhere. It tapped into something almost primal. There's still a giant undiscovered world hiding in our own solar system close enough to matter, and we just haven't found it yet. Newspapers ran illustrations of a shadowy blue giant lurking at the edge of the dark. Documentaries were made. For 9 years, telescopes around the planet have been hunting for it. They've been pointed at the darkest, emptiest patches of sky night after night. They've been hoping to catch a single pixel of reflected sunlight from something that might not even exist. Entire careers have been built trying to prove or disprove that it's really out there. And for 9 years it stayed exactly what it started as. A shadow on a chalkboard. A gravitational fingerprint with no hand attached to it. That brings us back to that grad student. It brings us back to that stack of archived telescope images. It brings us back to the object he wasn't even looking for. The team was led by astrophysicist Seheo Chung. He worked alongside Princeton researchers Jeshuan Lee and Eritas Yang. They weren't randomly stargazing. They were doing something closer to digital archaeology. They dug back through old survey data collected years earlier by powerful sky-scanning telescopes. That data had been gathered for a completely different scientific purpose. It had simply never been fully searched for objects like this. The dataset they used was drawn from a wide-field sky survey. It was originally designed for entirely different cosmological research. It wasn't even built with distant solar system objects in mind. It just happened to be sitting there unexamined. It contained exactly the kind of clue nobody had thought to look for. Their method relied on something almost deceptively simple in concept but brutally difficult in practice. Real stars and galaxies stay put from one image to the next night after night. Anything orbiting our own sun creeps slowly across the frame. It betrays itself through motion alone. Buried in 19 separate images spanning observations stretching back over a decade, they found a faint point of light that moved, slowly, consistently, in a pattern that could only mean one thing. This wasn't a star. It wasn't a smudge. It wasn't a camera artifact. It was something real orbiting our sun. Nobody had ever noticed it before. It had been sitting quietly in publicly available data for years. It was waiting for someone to finally connect the dots. What they'd found was almost immediately strange. Based on how much light it reflects and how far away it sits, the team estimates 2017 of 201 is roughly 700 kilometers across. That's a little over 400 miles. That's about the distance from New York to Detroit stretched into a ball. That's small compared to Pluto. But researchers believe it's large enough for its own gravity to have crushed it into a rounded shape over billions of years. That is the basic requirement for something to be classified as a dwarf planet. If that classification holds, 2017 of 201 would join a very short list. That list includes Pluto, Eris, Makemake, Haumea, and Ceres. That is the entire known population of confirmed dwarf planets in our solar system. It is about to gain a new member for the first time in years. And this new member would instantly become the one with the single widest orbit of them all. But size wasn't the part that made scientists sit up. It was the orbit. Right now, 2017 of 201 sits about 90 times farther from the Sun than Earth does. That number alone is already almost incomprehensible. Pluto, by comparison, orbits at around 40 times Earth's distance. Pluto already takes 248 years just to complete one trip around the Sun. But 2017 of 201 isn't just distant. Its orbit is one of the most extreme ever recorded for an object of its size. At its closest approach to the Sun, it swings in to about 45 times Earth's distance. At its farthest, calculations suggest it travels out to roughly 830 times that distance. That's deep into the inner edge of the Oort cloud. That's the vast, mostly theoretical shell of icy debris thought to surround the entire solar system like a thin, distant fog. It's so far out that sunlight itself, which reaches Earth in about 8 minutes, would need well over 4 days just to arrive there. A single orbit takes this object somewhere in the neighborhood of 24,000 years to complete. To put that in perspective, the last time 2017 of 201 was this close to the Sun, humans hadn't yet invented writing. Agriculture was still spreading across the planet for the first time. The last ice age hadn't fully released its grip on the northern hemisphere. The next time it swings back around, nobody currently alive will be here to see it. Nobody's great-great-grandchildren 100 generations deep will be here to see it. Every human being who has ever lived, every war, every empire, every book has happened during a single narrow sliver of this one object's journey around the Sun, ever written. Here's where it gets genuinely unsettling for the Planet 9 hypothesis. Remember that suspicious clustering Badigian and Brown discovered in 2016? That's the alignment that convinced them something massive was shepherding distant objects into formation. If Planet 9 really is out there doing exactly what the theory predicts, then any newly discovered object with a similarly extreme orbit should statistically fall into that same alignment. It should point in roughly the same direction as the others. It should follow the pattern. That's the way every other extreme object discovered since 2014 has more or less obediently done. 2017 of 201 does not follow the pattern. Its orbit sits at an angle wildly different from the cluster. Researchers have described it as roughly 90 degrees off from where the rest of the group points. It's an outlier so far from the expected alignment that it isn't a minor wrinkle in the data. It's a direct contradiction. The research team ran simulations testing whether 2017 of 201's orbit could coexist with the leading proposed location for Planet 9. The math didn't cooperate. The two didn't fit together no matter how the researchers adjusted the variables. That doesn't prove Planet 9 is fantasy. Nobody on the research team is claiming that. They've been careful to say so publicly. It's entirely possible that 2017 of 201 is simply a strange exception. It could be a single outlier in an otherwise valid pattern. Every dataset has a few. One contradictory data point rarely topples a theory built on years of independent evidence. But here's what it does mean. The clean, elegant story of a lone, hidden super-Earth quietly organizing the outer solar system into obedient formation just got a lot messier. And messier in science usually means something interesting is actually going on. Here's the part of this story that almost never makes it into the headlines. It's arguably the most important part of all. Chung and his team didn't just find one strange object. They found evidence that there are probably many more just like it. These objects are hiding in plain sight. They are waiting for someone to look at the right patch of sky at the right moment. Because of how 2017 of 201 moves, it spends the overwhelming majority of its 24,000-year orbit so mind-bendingly far from the sun that it's essentially invisible to every telescope on Earth. Researchers estimate it's only detectable even with our best instruments for roughly 1% of its entire orbital path. That's the small sliver of time when it happens to swing close enough to be seen at all. Think about the odds embedded in that number. We caught this object during the 1% of its 24,000-year journey when it happened to be visible. We caught it using a telescope that wasn't even designed to look for it. We caught it buried in data nobody had fully searched. That means statistically for every object like this that we actually managed to catch in that narrow window, there are almost certainly dozens. There could be over 100 similar objects out there right now that we simply haven't gotten lucky enough to spot yet. Based on the numbers, the research team estimates that this entire hidden population taken together could add up to roughly 1% of Earth's total mass. It is scattered across a region of space so vast, so dark, and so cold that we are only now developing the tools sensitive enough to even begin searching it properly. Sit with that for a second. We're not just talking about one lonely rock drifting through the void. We're talking about the discovery of a possible new frontier. It's a previously unmapped population of dwarf planet-sized worlds. It occupies a region of our own solar system that until very recently most scientists assumed was almost completely empty. It's a blank space on the map that may in reality be quietly crowded with worlds we've simply never had a reason or the ability to look for. That's the real headline hiding underneath the clickbait. It's not really about disproving Planet 9, even though that's the part that gets people to click. It's about the growing realization that the solar system we grew up learning about, 8 planets, an asteroid belt, Pluto demoted and forgotten, that might just be the small well-lit room at the front of a house with dozens of darker rooms we haven't even found the doors to yet. And the timing of this discovery makes it even stranger. This isn't some decades-old mystery finally getting closure. The updated peer-reviewed version of this research was only formally published in January of 2026. That means the scientific community is right now in this exact window of time actively debating what this object means. They are running new simulations. They are requesting time on telescopes like Hubble and the James Webb Space Telescope to get a clearer look at its surface and composition. Astronomers want to know what it's actually made of. Is its surface the deep reddish color typical of ancient unaltered ice similar to what's been observed on other extreme outer solar system objects? Or is it something else entirely? That color alone can tell scientists how long it's been baking in weak sunlight. It can tell them whether it originally formed closer to the sun and got flung outward. It can tell them whether it condensed out where it sits now in the near total dark billions of years ago. This is a live, ongoing story. It's not a settled one. Nobody currently knows how it ends. There's also a quieter, more technical debate happening behind the scenes. It rarely makes it past academic circles. It might end up mattering more than the headline itself. Some researchers studying 2017 of 201 have modeled how its orbit might have evolved over billions of years. They're testing whether it could have started somewhere entirely different. They're testing whether it slowly drifted through countless close encounters with Neptune's gravity into the strange path it follows today. If that migration story holds up, it means 2017 of 201 isn't some untouched relic sitting exactly where it formed. It's a survivor. It's a wanderer. It's a piece of solar system history that's been quietly rearranging itself for longer than complex life has existed on Earth. And it just happened to end up somewhere we could finally catch a glimpse of it. Early measurements already hint at part of the answer. The object appears distinctly red. It's redder than the sun by a wide margin. It's not quite as deeply red as Sedna, though. Sedna is one of its closest cousins in this strange, distant population. That reddish tint isn't cosmetic. Out in the freezing dark, billions of years of exposure to cosmic radiation slowly cooks the simple ices and organic compounds on an object's surface into deeper red hues. That process takes an enormous amount of time to happen. A surface that red is in its own quiet way a kind of clock. It's one more piece of evidence pointing toward an object that has spent an almost incomprehensible stretch of time drifting largely undisturbed far from the sun's warmth. It happened to end up exactly where a survey never designed to find it happened to catch it anyway. There's a strange emotional undercurrent to all of this that rarely gets talked about. For 9 years, an entire generation of astronomers has organized huge amounts of research telescope time and career-defining ambition around the hope of finding one specific hidden planet. They wanted a single dramatic answer to a mystery in our own cosmic backyard. Grants were written around it. Doctoral theses were built on the assumption it might eventually turn out to be real. And what they may have stumbled onto instead is something less tidy and less cinematic but arguably more profound. It's not one hidden giant. It's an entire unseen population of smaller worlds. They've been quietly orbiting in the dark for the entire span of human civilization. They've been waiting patiently to be noticed. There's something almost humbling in that shift. The story we wanted was simple. One planet, one answer, one triumphant discovery photo. The story we might actually be getting is messier. In its own way, it's more honest about how the universe usually works. There's not one grand secret. There's a whole hidden layer of smaller ones. They're scattered and waiting. They're indifferent to whether we ever bother to look for them. Chung himself hasn't given up on Planet 9. He said publicly that he intends to keep searching for it. He's saying this even as this new discovery complicates the case for its existence. That's not scientific stubbornness. That's how real science actually works. A theory doesn't collapse the moment one piece of contradicting evidence appears. It gets stress-tested, it gets argued over, it gets refined. Sometimes it gets discarded. Sometimes it gets strengthened by the very data that seem to threaten it. Right now, Planet 9 sits in exactly that kind of limbo. It's neither confirmed nor disproven. Its most famous piece of supporting evidence is now sitting uncomfortably next to an object that doesn't play by its rules. Here's what we do know with much more confidence than we did a year ago. Our solar system does not end where the textbook suggested it did when most of us were in school. There is a vast, mostly unmapped territory beyond Neptune. It's beyond Pluto. It's beyond the edge of anything we've ever sent a spacecraft to visit. It has been sitting there unexplored for the entire history of human astronomy. It's not because it's empty. It's because it's dark and cold and almost unimaginably far away. We simply didn't have the tools to look closely enough until now. For most of the 20th century, the assumption was simple. Past Neptune, things thin out fast. There's a scattering of icy debris, including Pluto. Then there's essentially nothing until the sun's gravity itself starts losing its grip somewhere out near the neighboring stars. That assumption wasn't lazy. It was based on the technology available at the time. Objects this small, this dim, this far away reflect almost no sunlight at all by the time it reaches our telescopes. Finding them isn't like finding a bright star in a dark sky. It's closer to trying to spot a single grain of dark sand sitting still somewhere across a football field using nothing but a flashlight from the opposite end zone. Every year cameras get a little more sensitive. Every year computers get a little better at sifting through millions of images for the one pixel that moves. Every year a few more of these grains of sand get found. Entire survey projects built with billion-dollar telescopes and years of observing time exist purely to keep expanding that search a little further into the dark, one faint pixel at a time. 2017 of 201 is simply the newest and for now one of the most extreme examples of exactly that slow, patient process finally paying off. It's worth remembering too that this isn't the first time an assumption about the edge of the solar system has quietly collapsed. Pluto itself was once considered the outer boundary. It was once considered the final marker before nothing. Then came Eris. Then came Makemake. Then came Haumea. Then came Sedna. Each one pushed that boundary a little farther out. Each one was a small reminder that the edge of what we know and the edge of what exists have never actually been the same line. Sedna was discovered back in 2003. It was the first real hint that something like this population might exist. It's an object with such a bizarre, stretched-out orbit that it barely seemed to belong to our solar system at all. It spends most of its multi-thousand-year journey so far out that even calling it ours feels like a stretch. For years Sedna sat alone. It was an outlier with no obvious siblings. 2017 of 201 is proof that it was never really alone. It just took 2 decades and a much more thorough search of old data to find the next member of its family. 2017 of 201 is just the latest name on a list that keeps getting longer. It's a pattern that has repeated itself quietly for the last 2 decades. 2017 of 201 won't be visible again for tens of thousands of years after this window closes. Somewhere out past the orbit we can barely track it in, it will fade back into darkness. It will continue its silent 24,000-year loop long after every scientist currently studying it is gone. It will continue long after every person watching this right now is gone. But for this small narrow slice of cosmic time right now this year it's visible. It's here. And it just handed us proof that our own solar system is still keeping secrets bigger than anyone expected. So the next time you look up at a clear night sky and think you know what's out there, remember this. Somewhere past the edge of everything you can see there are worlds we haven't found yet. It took modern telescopes and archived data and a small team of researchers combing through old images almost by accident to even notice this one. Not one world is out there. Possibly dozens are out there. They are quietly orbiting unnoticed. They are waiting for someone to finally look in the right place at the right time. We just proved there's more out there than we thought. We still don't know how much more.